Hello and welcome to today's video. So as you can see on the workbench, the power controller. I've spent the evenings after work soldering these puppies up. There's a time-lapse video of all that. I will include that at the end of this video. So this video may seem super long, but in reality the rest of it will just be time-lapse. So this is a power controller. Its main primary purpose is to open up the contactor. It closes or opens it, handles pre-charging, and monitors if we have an overvolt, it'll open it, undervolt, it'll open it. Battery temperature goes too high or too low, it can open it. Cell out of range, so anyone's cell goes high or low, over the threshold, we can open it. You name it, it'll open. Its primary purpose is to open the contactor to disconnect the battery pack from the main system bus. Because I'm going to have 4 battery packs connected in parallel, and if you had a cell failure and one of your cells is shorted, we don't want power flowing from one battery pack to the other and trying to charge it up, because that'll overvoltage the other cells, and then we'll have a runaway condition and fire and bad things happen. So this guy monitors the voltages, the currents, the temperature, current, everything. So it came out pretty good. I'm quite happy with it. It is probably incredibly over-engineered. It is 100% isolated from the high voltage side to the low voltage side. So this A side gets connected to the battery pack through a fuse and possibly the current sensor. Current sensor can really be anywhere. It can be on the output. It can be on the return line, ground, it doesn't matter. It measures essentially from the A side to the ground of the battery pack, and then B side to the ground of the battery pack. Because in my vehicle, all of my battery packs will be connected to a common ground. The contactors are just going in the high side. So what you would do is it receives a command, and it will turn on these 2 IGBTs via these white photo gate drivers. They're essentially like little photodiode array that shines on essentially a solar cell, and it applies a voltage to the gates. It turns on very slow, but that's okay. We only need to do the max we can ever do is 3 amps, because we have a 50 ohm resistor. My nominal battery pack voltage is 150 volts, so that's 3 amps. So I'll be passing 3 amps from the A side to the B side, charging up some capacitors, and they'll charge up really fast. So it'll only do that for it'll pass current for maybe a quarter of a second, half a second or so. Once it says it can measure both of those sides and goes, oh yeah, they're about the same voltage, then this connector will tell the contactor to turn on. So there'll be a cable that goes from here to there, plugs in, tells the contactor, hey, turn on. And now we're bypassing, in the pre-charge everything shuts off, and we're now passing current through, full current capability. The other connectors that we've got on here, there's an auxiliary contactor. Probably this can be used, well, I say auxiliary contactor, it'll drive another contactor. Both of these can do what's called an economizer, so it just can PWM. It uses full power to pull in the contactor and then PWMs it to reduce the current consumption. So both of these outputs can do that. This can be used to drive, say you had a negative side contactor as well. Something like that. Gotta have the arrows pointing in the right direction. So current would come out of your battery pack and then back through here. So you could set this up so that this connector goes over, plugs into here, and turns on. So anytime a pre-charge or main contactor is being commanded to turn on, then this guy would turn on as well. So that works for if you have a high side and a low side contactor. But like I said, I'm not planning on having a low side contactor. All mine are just going to be connected to ground, or all connected together. The other option is to use this to go to your motor controller and or battery charger, so that if there is an error event, something's out of range, an anomaly has occurred, you can momentarily short out the throttle pot on your controller so that it puts out 0 current to allow the contactor to open and close, or to close, or to open, so it doesn't have to switch under load. It can, but that wears them out pretty quick. Same with battery charger. It could turn off an AC relay to your battery charger. Once the battery is fully charged, it can, if for some reason your battery charger doesn't accept a command or doesn't read the voltage and stop, if something went wrong with it and it's just, putting out tons of current, you could use that to open up the AC power to the battery charger to remove it, to keep it from charging. So that works either way. This connector is just 12 volts ground CAN bus, so that's how it receives its communication, and it can monitor the other guys. Each one's got a little unit ID right here that sets its address so they can talk to each other, so they can specifically for current sharing, we want to make sure that everybody's the same amount of current's flowing into every battery pack and coming out of each battery pack. If there's a large anomaly, then we can open up the contactor, disconnect that one that's acting funny. That would mean that one of the cells is going bad or something's wrong with it. Maybe it's an open cell, who knows. Let's see what else. This connector here goes out to the current sensor, and it can support, this is the one I'm going to be using, these, what is this, it's a CSLA 2D6 current sensor. I believe it's a 225 amp current sensor, and this needs between 6 and 12 volts to run. I have a, on the back here is a linear regulator adjustable that sets its output to 8 volts. And that powers this guy, and then it's got a op amp on here that takes the, because this is ratiometric, it actually puts out 4 volts. Its current signal is plus or minus 2 volts, full scale, centered around 4 volts, and then through a little op amp here on this side, I change that over to 0 to 5 volt full scale, centered at 2.5 volts, which is what the current or the A to D converter on this microcontroller is looking for. Same with that's what the Leaf current sensor puts out, but it's on this weird bus bar that I really can't use because it puts it in weird, awkward positions, and yeah, it's just not usable in its current state. But yeah, this takes 5 volts and spits out full scales plus and minus 2.5 volts centered at 2 volts. So full negative is 0 volts and full positive is 5 volts. So this will also can interface with that. You just change one resistor over here so that the regulator, instead of putting out 8 volts, it puts out 5 volts, and that works perfectly fine with that. So just as a system mock-up, I've got one board bolted on to the contactor here. This isn't how I'm going to do it. The posts are a little too short. So if you look, what you want to do is have this guy bolted to the contactor, and then the circuit board goes on, and then another nut, so that we have a lot of clamping force between this and that, and you're not relying on squishing the fiberglass of the circuit board to get all your clamping force, because that won't work. This is just not strong enough. So when you torque this down, you want to have the nut directly on this piece of metal, on this connector. And I know some people don't like these connectors, but I like them. I've used them for all the years of my truck. They work perfectly fine. I've never had any problems with them. But I know some people prefer the crimp kind, but this is probably what I'm going to use. Yeah, I don't know. I like them. So when I made this, I made it so that those would function. You could change angles, but I'm probably going to have it come across like that. But like I was saying, the posts are too short, but that's not a problem, because on the contactor, you can take out the screw here. Probably shouldn't have put it back in. So bear with me for a couple seconds here. So you can take that out, and then this just slides right on out, and it's just a nut, or a bolt. So you can actually, get a longer one or do whatever you want with that. And then once you're done, put that puppy back in and tighten the screw. So, it's not the end of the world. I was a little worried, but once I figured out that comes apart, I'm like, oh, well, that's not that big a deal. Because my other option is to get thinner versions of these. But these seem to become some kind of standard thickness, because my fuse that I'm planning to use, this 200 amp, 170 volt fuse, is exactly the same thickness. So I think that's some kind of standard thickness. Maybe that's how thick something needs to be for 200 amps. I don't know. But yeah, so that's going to work out fine. I was a little worried about that, but it looks like that's going to be okay. So as my little mock-up here, if you imagine the battery's out here somewhere, positive terminal on the battery, you're going to come in. I'll probably just bolt this right to the positive terminal on the battery because you want your fuse as close as possible to the battery pack. So you can't get any closer than bolting it to the highest positive terminal. So I'll bolt that right on there. The other side will have, one of these guys. We're going to 2-gauge cable. And along this 2-gauge cable will be my trusty current sensor. So, it just kind of hangs out in there. And does its job. So it's sensing current. We've got that. And the other end of this will, of course, plug into here. Come in here. And then this side will go out to the main common system bus that goes to the motor controllers, DC-DC converter, power steering, air conditioner, everything else in the vehicle. And yeah, so that's pretty much it. The ground return will just be another 2-gauge cable going back to the other side of the battery, so it doesn't go through anything. If it's convenient, I could put the current sensor in the ground return, but I'll probably just stick it like it'll literally be like right here and just zip tie it on there or something. So that shouldn't be too bad. And then of course, everything's gonna be wired 2-gauge. Cruising down the highway, I'm really only gonna be drawing like maybe 40 amps because I'm gonna have 4 sections and they're all gonna be providing like 40 amps. So it's not like a ton of current. This is probably super overkill. But acceleration, you could draw a lot of current. I'm fusing the system at 200 amps for each module, so that will allow me to draw, 4 times that. So 800 amps. My controllers can't draw that much current, so they max out at 280 amps each. So was that 560 amps max is all I can draw. So I think I'll be okay. Even if and that's in performance, and typically I don't drive in performance, I drive in economy or normal mode. And the truck's going to weigh like 600 pounds lighter too, so even then, economy is probably going to be perfectly fine. And I think in economy I only draw probably 150 amps or so total in economy mode, so even then it'll be less. Yeah, but anyways, this video has been pretty long, but next should be the time lapse of these being assembled. Yeah, so anyways, thanks for watching. Bye.